What's up, everyone? My name is Dr. Chris Hacks, and welcome back to the CryptoPals Crypto Challenges. Today we're going to be doing challenge number 4, detecting a single character XOR. So one of the 60 character strings in this file, which I'll open right here, has been encrypted by a single character XOR. So we have to go through and find it. So what we'll be doing is we are going to download this file, which I've already done beforehand. We'll add it to our project, and our code will iterate over every single line and try every single character key in order to try to decrypt it. So let me just jump right in and I'll show you what we're doing. So if we go over here to our code, basically what I already have here is I created a new filter called challenge data because multiple challenges in the future are going to have a lot of text files that are associated with them. So it's good to have a filter here. We have this file called for.txt, and this is just all of those lines that they provided us from earlier. Okay, so what we will do is we will open and read our file. We're going to have to read through everything in order to actually do operations on it. So we'll read each string, each line into a string and then do some stuff with it. And then we're going to iterate over every single line. So iterate over every line. So we'll go over every single line in this file in order to find the one that is actually encrypted, and then we're going to actually iterate over every single character possible from 0 to 255 in order to try to find the key. So over every char, and then what we'll also do is we're going to score everything. So using our heuristics function from last time, we will score all of the different decrypted lines, and then whichever one has the highest score is the one that's most likely to be English plain text, and that's the one we will return. So let's jump right in. The first thing I'm going to want to do is over here in the challenges.h header, we're going to be using this throughout the rest of the challenges. Not all of them, but a good number of them. So I'm going to include stream. That way we can actually open up our file and read from it. Alright, if I go back to challenge 4 over here, now I can just get started. So we're going to create an if stream to open our file. I'll call it file, and we are going to pass in the file name, which is going to be for.txt. This will open our file and allow us to actually read it. Next, we'll do a little bit of error checking. It's always good to have some of that. So if not file.isOpen. So if the file's not open, then that means something went wrong. And we could throw errors, or you could return like the error string. We will end up throwing errors later in this course, but for now, I'm just going to return a string giving us the error message. It's going to say file for.txt failed to open. That way, if the file fails to open, we will know and we can go and troubleshoot that. Okay, but after that, let's assume the file is open. So what we'll do is we'll have a while loop going. So what we can have here is while get next line, or rather while get line. So we're going to use standard get line, and we will pass in our file and then a string. So let me make a string real quick. Standard string line. We'll just have that, and we'll have a line here. So so every time this reads a line, it will return true. So our while loop will keep running, and it will populate the line into our string here. So now that we have our line populated, what we can do is start actually iterating over all of the characters. So what I'm going to do first is hex decode it. So std string, or I'll call it ciphertext because it is encrypted. Hex. Oh, I do need to include our utils header to make sure this works. Encoding utils. Perfect. Okay. While hex to text. And then we will pass in our line. That will give us our ciphertext. Oh, if I actually define this all correctly. Perfect. Okay, and now that we have our ciphertext, we can just simply iterate over it. Let me also include our heuristic function. So include heuristics.h, that way we have access to our scoring function. Okay, so for, and then we'll use every single char. We'll use an unsigned character C equals 0, C is less than 256, and then C++. Okay, perfect. So, like last time, we will have a string called key, and all it will be is a key that uses C as one of the parameters, and the size will be the cipher text. Let's call this ciphertext dot length or size, either or. Okay, so this gives us our key, and we can do our XOR function on this. So we'll call it std string plain text equals fixed XOR, and then we'll XOR our ciphertext with our key, and that will decrypt it. Now, we do need to keep track of the scoring. So what I'm going to do up here is I'm going to create some variables. We'll call it double best score. Okay? So we'll find our best score. We'll set it to 0.0 for now. And we will also have double best string. And that will just be, or I'll call it best plain text. And that'll just be a blank string for now. That way we can actually store it, and then we will return it. I'm sorry, not a double. This should be a string. We'll store our best string, and then we'll return it so that we can do that. You can also store the line. Basically, you'll have a variable that holds the line count. You increment it every time this while loop runs if you want to return the line that it's found on. You can do all that if you would like. So actually, let's go ahead and do that as well. We'll call it int best line. That way, we have a way to track that. And I will also have a thing called, let's just call it L, the line's already taken, and we'll use that to track the line number that we're actually on. Okie dokie, so down here at the end of our while loop, let me just increment our line every time, and then inside of our inner for loop, we will check our best score. So the way to do that, we'll have a double score, and that's just going to be equal to score text. We'll pass in our plain text here. That will give us our score from our heuristic function from earlier, and we can use that. So if score is greater than best score, then we will go ahead and populate everything. So best score equals score, and then best line equals L, and best plain text equals plain text. Perfect. Okay, so that should track everything. Alright, once we're done reading everything, we can go ahead and make sure to close our file. It's good practice to do that, just to make sure we don't have anything left over at the end. And I believe we can just return our plain text. Return best plain text. Very good. Actually, I'm going to change this a little bit. I'm going to also return our line. Because we are tracking the best line, let's build a string real quick. So we'll return this. Best score of, and then we'll do this. Let's put best score here. Plus, oh, I need to convert this to a string real quick. So the standard library has, I believe, std.toString like this. Yes. So I can just pass that in just to be case. Best score of that at, put this in quotes, at line, and then we will do standard.toString of best line. oh, I need the plus here to concatenate the strings together, and then we need, oh, let me include a space here as well. Yep, space with plain text. Okay, I can get rid of this. I'm just trying to make it look nice and neat. I mean, we already did all the code, but you do want it to have a nice output so that it looks pretty. And then, oh wait, I don't need to do this. This is just already a string. We can just return best line. Perfect. So let's go ahead and run this and see how it works. It might be a little slow because we do have multiple for loops. Oh, let's see what went wrong. I think ill-defined for loop, body not executed. Oh, I had the same issue last time. What did I do wrong here? Unsigned star. What did we do wrong here? Hold on. Let's see here. Alright, so let's look up our error list. Okay, so there's a couple things in here. First off, this down here. Oh, best line is the wrong thing. It should be best plain text. That's why. Okay, so that's one thing. Then it's saying ill-defined for loop. I believe we did have this same problem in challenge 2. Let me reference that again. Oh, I did set it to 255. I think that might be the issue. I might just be having my numbers off slightly. Let's see if that goes ahead and fixes it. Okay, it looks like it's running. Best score with that. That definitely does not seem right. Okay, so I know for a fact that is not correct. So let's go ahead and debug this a little bit. I'm going to go through and figure out what went wrong. Okay, so after a little bit of debugging, I noticed what I got wrong. Here at the string declaration, I did switch my parameters by accident. Also, I did mention this earlier in the last video. We may need to revise our heuristics function. In this case, we do. So what I'm going to do is I'm going to jump into the definition for this function, and I'm going to add a little bit more. So right now we have frequency scoring, which works. However, if we look at this text that is output real quick, we can see that some very common English letters are appearing in here, like E's in here, which does sort of affect the score with really low strings. Say, for example, you have like the quick brown dog jumps over the lazy fox. That has every single character in English. However, it would score very low because the frequency distribution of that sentence doesn't match what we would expect in a large body of natural text. Therefore, what we need to do is we need to add another metric to sort of offset that a little bit. Now, there's two metrics I like to use. You can use letter count and non-printable character count. So if there's non-printable characters, you can almost certainly penalize that significantly. We don't want any sort of non-printable characters because chances are that would not be the correct string. There may be some strings that do have a non-printable character or two, but when it's like 20 non-printable characters and it's like a 40 character string, it's almost certainly not the answer. Also, checking for alphanumeric characters and spaces can be a good start. So for now, what we're going to do, we're just going to have a non-printable character scoring metric. So what I will do here is we will just add another sort of for loop that checks if it's a non-printable character or not in each string that's added, and then assign a weight to that. So what I'm going to do is I'll just count printable characters. Okay. So we will have int printable char is equals 0. And then for, character C in the input, if it is standard is print, I believe. Yep. So let me just make sure. So this will check if it's a printable character. or if it is a new line, I believe it doesn't count. Actually, let me check that real quick. Yeah, so it does not count new lines or any of those types of characters. So if C is a new line, or if it is a tab, oops, didn't mean to do that. Sorry. Or if it's a tab character, or if C is a return character. So if C is printable or one of those three special characters, then we will increment printable chars. And then at the end, what we will just do is we'll have a double printable ratio is just equal to, oh, I'll move that in a second. Let's do this. Static cast double, and then we will do I will do it this way. I will actually do it this way so we don't have to do any weird casting. We'll just have this be a double at the beginning so our division is correct. And we will do printable chars divided by input dot size. And I also noticed I put this inside the middle of where our frequency analysis is. So let me just move that to afterwards. Down here. So number 2, count printable chars after our frequency score. Okay, and then for now, what we can do is we can just have a simple ratio. I'll just do this. Frequency score plus printable ratio. That will give us some score, and then we will divide it by 2. Let's see if this is enough to find the correct thing we're looking for. Assertion failed. C is, let's retry real quick. Let's see what happened. Is print or C or C or C? What did I do wrong here? I see. So it looks like for some reason our input isn't working correctly. Every character should be 8 bits. Here, let me think for a second. Yeah, let's try this. Let's make sure it's an unsigned character. That should fix the issue. I believe. Yep. Okay, cool. Okay, so it gave a score of this to this plain text, which is once again incorrect. So this doesn't match the frequency, but it has all printable characters. Therefore, it's scored higher. So let's add one more metric. One more thing we can do to factor this down even more, it's very likely that we're going to have alphanumeric characters. So count alpha num char characters. And the reason for this is a lot of the time in English text you will have a lot of letters and numbers, more so than special symbols like we just saw in that last one. So what we can do is double alpha num chars equals 0.0, and then for unsigned char C in input, if standard is alpha num of C, or it's a space. I'll count spaces as well, just because those are common. If that, then we will increment alpha char. So alpha num chars plus plus, and then double alpha num ratio. Alpha num chars divided by input dot size. Okay, now we can add that in, and we can divide by 3. And this should give us enough weight to get the correct screen. Yes, there we go. Best score of 10. A score of 10 is a little high, so let me figure out what went wrong there, but this is the correct line. Now that the party is jumping. So that is the correct line, so we know that it's producing the correct line. So yeah, if you guys want to stop here, this is good. I'm going to do a little bit more troubleshooting. I wonder why it is so high. It really shouldn't be. It shouldn't be at 10. That is a little bit too high. Our score should be between 0 and 1. So let's take a look at what's going on here. So we're just simply incrementing this for every single character, and then we're dividing by the size. So let's go ahead and do this. I'm just going to do a little bit of debugging, a little trick. So let's include IOStream. You could use breakpoints. I'm not a big fan of them in C++, just because it is a little bit I'm just not the biggest fan. I like my print statements. It's a little amateurish, but they work. So what we'll do is if no, those are all doubles. Let's just do this. If this is greater than 10, 0, then we are going to cout, or std_cout, freak score. We're going to cout the printable ratio. We're going to output the alpha numchars, and we're going to output the input.size. And that should give us enough information to debug. So let's throw all that stuff in there. And I'll just separate them all by some spaces just to make it a little bit easier to read. That should be good. So let's see what it outputs here. Okay, so it looks like our printable ratio. Oh, duh. Of course, I'm using alpha char. I should be using alpha num ratio. Of course. That's what was causing the issue. I see. That makes more sense now. Now, if we run this again, it should give us a score that is less than 1. Yep, that score of 0.77, which is what we are more looking for, because it's between 0 and 1, just to keep everything normalized. Alright, very cool. Now that that is done, I'm going to go ahead and I'm going to get rid of all this stuff. I'm only going to return the plain text, and we can run it one more time just to ensure that everything's working properly. And there you go. Now the party is jumping. So that's how you do the XOR function, and that part really wasn't the hardest. It's really the heuristic algorithm that is a little bit tricky. There's a number of different ways to do this. I use my frequency scoring with printable characters and alpha num characters just because it is reliable and it can give you some good English text, but there's a number of different ways to do this. So feel free to play around with this and tweak this algorithm a little bit, or even completely throw it out for something new. There's a lot of different solutions to this problem, so it's worthwhile playing around with it. But anyways, I'm going to upload this to the GitHub for y'all to see, and thank you all for watching, and tune in next time for the next solution to challenge number 5.